All right, so in example 4, we're actually given functions and asked to determine whether the functions are concave up, concave down, or neither. And so when you're just given a function, we saw how to do it with a graph, we saw how to do it with a table. Given the function, it'd be nice to have a graph or a table, right? Um, so from the function, we can easily create a table. Now you could, if you have a graphing calculator or want to use some graphing tool, um, you could graph it, or you could graph it by hand. Just be aware that during a quiz or a test, you're not going to have access to some online graphing tool. And I'm going to want to see your work. So let's do this by uh, creating a table and looking at the average rate of change over intervals. Okay, so we want to find the concavity of f of x equals x cubed for x greater than 0. All right, so one thing we can do is we can just plug in some values. So at 0, we're at 0, right? At 1, we're at 1. At 2, we're at 8. At 3, 3 cubed is 27. We could keep going, but we're just going to determine whether it's concave up or concave down from this amount of information. Okay. All right, because we're given the interval x greater than 0. So, all right, so let's look at the average rate of change. All right, the average rate of change over this first interval is just going to be, okay, the change in uh, f of x went up by 1, and x went up by 1. So that's just 1, right? Here, the next interval, f of x went up by 7, right? For an increase in x of 1. So this is just an average rate of change of 7. And the next interval, it looks like it went up by, what is that, 19 for a change of 1. So this is 19 over 1, which is just 19. Okay? So it looks like the average rate of change is increasing. Okay, so the average rate of change is increasing, so so it's concave up. Is concave up. All right, let's take a look at the next function. All right, now I'm just going to create a little table again for this of x and g of x, and plug in some values. So 0, so it says x is greater than 0, so 0, 1, 2, 3. Let's see what happens with those values. Okay, if we plug in 0, we get 0 times 12, which is 0, over 0 plus 2, which is 2. So 0 over 2 is 0. Plug in 1, we get 12 over 1 plus 2, which is 3. So 12 over 3 is 4. If I plug in 2, I get 24 divided by 4, which is 6. I plug in 3, I get 3 times 12 is 36 over 5. So I'm just going to write that as 36 over 5. I can't really reduce that. Whoops, 30. I'm supposed to be 30. I'm supposed to be 36 over 5. All right. So 36 over 5 is about, what is that? It's going to be 7.2. That's 7.2. Okay. All right, so now let's look at the average rate of change for each interval. All right, so now the change in x in each case is just 1, so everything's going to be over 1. So really all I have to do is find the change in the function, and then it'll just be divided by 1 to get the average rate of change, since I've got a nice increments of x of 1. All right, so this gives me an average rate of change of 4, right? 4 minus 0 over 1 minus 0. This interval has an average rate of change of 2, right? 6 minus 4 over 2 minus 1. And this average rate of change is 7.2 minus 6, so that's 1.2 over 1. All right, so what's happening to the average rate of change? It's decreasing. Decreasing. And what does that tell us? That tells us that g of x is concave down. All right. That takes care of all the examples, and I will meet you in class.